Hi everyone! Today we're diving into one of the most fundamental concepts in economics, elasticity. Specifically, we're going to focus on price elasticity of demand. But before we start, let's refresh our memory on the law of demand. The law tells us that when the price of a good increases, the quantity demanded decreases, all else being equal. It's an inverse relationship: price up, quantity down, price down, quantity up. But here's the real question: how much does it change? If a price goes up, does demand drop a lot, a little, or not at all? That sensitivity is what we call elasticity. Let's look at 3 different scenarios. In all 3, we assume that the price increased from P1 to P2, but notice how the results change based on the slope of the curve. In scenario 1, the curve is very steep. In scenario 2, the curve is less steep. And finally, in scenario 3, the curve is very flat. Comparing the 3 scenarios, we notice that the quantity demanded dropped only by a tiny bit in scenario 1. So this demand is less sensitive to price changes. In scenario 2, the drop in quantity demanded is more moderate. So this demand is moderately sensitive to price changes. In scenario 3, that same price increase caused a massive crash in quantity demanded. This demand is highly sensitive. So the steeper the curve, the less sensitive the demand. The flatter the curve, the more sensitive the demand. Now, how do we measure this sensitivity mathematically? The price elasticity of demand is usually represented by the Greek letter epsilon p or eta or capital E. Elasticity is a measure that compares the percentage change in quantity demanded with the percentage change in price. By rearranging the math, we get the most common version used in microeconomics textbooks. That's most common formula version of price elasticity. Now let's apply this formula. Suppose that business travelers and vacationers have the following demand for airline tickets from Chicago to Miami. Let's solve A first. As the price rises from $200 to $250, what is the price elasticity for each group? Starting with business travelers, when the price increases from $200 to $250, the quantity demanded falls from 2,000 tickets to 1,900 tickets. Let's plug these values in the elasticity formula. Delta Q is 1,900 minus 2,000. Final value minus initial value. Delta P is 250 minus 200. Final value minus initial value. P1 is the initial price, 200. Q1 is the initial quantity demanded, 2,000. So delta Q is equal to minus 100, and delta P is equal to 50. Minus 100 divided by 50 is minus 2, and 200 divided by 2,000 is 1/10. Minus 2 multiplied by 1 is equal to minus 2 over 10. Minus 2 over 10 is equal to minus 0.20. How do we interpret an elasticity equal to minus 0.20? This means a 1% increase in price leads to a 0.20% drop in quantity demanded. If you're enjoying this content, don't forget to subscribe to our channel to help us grow. Now, for vacationers, when the price increases from $200 to $250, the quantity demanded falls from 800 tickets to 600 tickets. Delta Q is 600 minus 800, final value minus initial value. Delta P is 250 minus 200, final value minus initial value. P1 is the initial price, 200. Q1 is the initial quantity demanded, 800. So delta Q is equal to minus 200, and delta P is equal to 50. Minus 200 divided by 50 is minus 4, and 200 divided by 800 is 1/4. Minus 4 multiplied by 1/4 is equal to minus 4 over 4. That is equal to minus 1. How do we interpret an elasticity equal to minus 1? For vacationers, an increase of 1% in price leads to a fall of 1% in the quantity demanded. Now let's work on letter B. Why might vacationers and business travelers have different elasticities? Vacationers have high flexibility. They can change their vacation dates, choose a different destination, or simply decide not to travel at all. This makes their demand highly sensitive. Business travelers, on the other hand, cannot have that luxury. They have meetings to attend and specific schedules to keep, so their demand is less sensitive. Therefore, a 1% price increase causes vacationers to drop their quantity demanded significantly more than business travelers. This leads us to a key conclusion. The more negative the price elasticity of demand, or the higher the elasticity in absolute value, the more sensitive consumers are to price changes. Now let's summarize the relationship between price elasticity and sensitivity of demand. The more negative the price elasticity of demand, or the higher the elasticity in absolute value, the more sensitive consumers are to price changes. Alternatively, the less negative the price elasticity of demand, or the smaller the elasticity in absolute value, the less sensitive consumers are to price changes. We usually look at the absolute value, ignoring the negative sign, to classify demand. If the absolute value of epsilon is greater than 1, demand is elastic. This means a 1% change in price leads to a greater than 1% change in quantity demanded. The change in quantity is more than proportional to the change in price. If the absolute value of epsilon is equal to 1, demand is unitary. A 1% price change results in exactly a 1% change in quantity. The change in quantity is exactly proportional to the change in price. If the absolute value of epsilon is less than 1, demand is inelastic. A 1% change in price leads to a less than 1% change in quantity demanded. The change in quantity is less than proportional to the change in price. Now let's go back to our example and classify the demand for business travelers and vacationers. We calculated that price elasticity for business travelers is minus 0.2. In absolute value, that's 0.2, which is less than 1. Therefore, their demand is inelastic. On the other hand, the price elasticity for vacationers is minus 1. In absolute value, that's exactly 1. So, their demand is unitary. Before we wrap up, let's take a look at two extreme cases of elasticity. Perfectly inelastic demand is represented by a vertical line. This means that no matter how much the price rises, the quantity demanded stays exactly the same. In this case, epsilon p is equal to 0. On the other hand, perfectly elastic demand is represented by a horizontal line. Even a tiny price increase causes demand to drop to 0. In this scenario, the absolute value of epsilon p is equal to infinity. This typically happens in perfectly competitive markets, where consumers can easily switch to an identical, cheaper alternative. That's it for today. If you found this helpful, don't forget to hit the like button and subscribe for more Economics Simplified. See you next time.